What's up guys, welcome back to the channel. In this video we're going to be learning about AprilTags and vision processing and just the basics of how to use those to use our cameras in FTC Center Stage. So without further ado, let's get started. So AprilTags are these barcode-like images that are placed around the field in this year's game. So you've probably seen them on the backboard right over here. Right, there are 3 AprilTags on the backboard, which can be very useful for scoring pixels. And then, something which is lesser known is that on the back wall near the pixel stacks, there are also these 2 big AprilTags that can also be very useful, right? So the whole purpose of AprilTags is that they can tell you information about the location of your robot just by looking at them, which is pretty incredible when you think about it. So just by looking at an AprilTag, your camera can tell you, okay, our robot is 2 feet away from it, 1 foot to the side, and is at a 25-degree angle. And that can be very useful for aligning, right? So for example, whenever you place your robot down, there's going to be a minuscule amount of error, which is just due to human error, right? So I can accidentally place my robot 3 degrees to one side, but then if in autonomous mode I have it aligned to the AprilTag, I can eliminate that error and make sure my movement is very accurate, right? So that's the real nice thing about AprilTags. So to get started, we have to use something called Vision Portal, which is something created by the nice people at FTC, which makes interacting with our camera a lot easier. So a Vision Portal is, as the name suggests, an interface between the camera and the code that allows for an easy implementation of vision features, such as AprilTags. Now, vision portals process the images that are received by vision processors, process the images that are received by the vision portal and analyze them, such as by searching for AprilTags, right? So now that we know this, let's start working the code to create a sample vision portal and vision processor. All right, now we're going to actually start coding our sample code, which is just going to be an autonomous mode that continually looks at the camera and adds to telemetry the distance to the AprilTags, right? So to do this, we're going to create a linear OpMode. You can also create an OpMode, whatever you prefer, but in this case, we're just going to create a linear OpMode, and we're going to set its name and group. So these are the camera's calibration values. Just put in some random numbers for now. We're going to figure these out in the next video. So these are just our camera's calibration values, and just forget about this for now and put some random numbers. You can even put whatever. For now, like 1, 2, 3, 4, or something like that, right? It doesn't matter for now. So now we're just setting this Boolean calibrated camera. That just for something later in the code, don't worry about that. And something that you do have to add is your AprilTag processor. So as mentioned before, this is your vision processor. This is what's going to process the image that the vision portal gives you, and it's going to give you an output, which is going to be the AprilTags it detects and the distance to those AprilTags. So next we have run OpMode. So now this is the thing I was talking about with camera calibration values. So basically, there are these values in the camera called fx, fy, cx, and cy. So fx and fy are the focal lengths in the x and y direction, and cx and cy are the position of the center of the camera in terms of the x and y, right? And for most cameras, these are not calibrated, right? The FTC SDK can calibrate these for every camera, and you're going to have to go through a camera calibration procedure, which I'll outline in the next video. But if you're lucky and your webcam is one of these webcams in these specific resolutions, make sure that the resolution is the same. That is very important as well. Then you're good, right? So then to create the processor, all you have to do is say AprilTag processor.easyCreate with defaults, and you have your AprilTag processor. Perfect. Unfortunately, for most of us, we're going to be using different cameras, so you're going to have to create a longer version of the same code. You're going to say AprilTag processor is a new AprilTag processor builder, right? And then you're going to have to set the lens intrinsics. So that's the focal length X, Y, CX, and CY that I was talking about. right? And then you're gonna have to set those lens intrinsics, and then you can also set some other parameters, like if you want to draw stuff, and then you just build that. So that's creating the vision processor done. And then you need to create the vision portal, which is what accesses your camera. So to do that, you say vision portal, and then you name your vision portal. I just called it vision portal as well. Is a new vision portal builder. So we could do easy create with defaults, but I think most people would like to have some more fine control over their builder. So you would return a new vision portal builder, and then you would set these methods. So you'd set the camera. So that's what you'd find in your code. So in your driver hub configuration. So we named ours webcam1, which most people should. And then you importantly need to add the processor. So you're saying, so this webcam, I want to add this processor, which is the AprilTag processor we created above. And then you're also going to want to set the camera resolution, which depends on your camera. So some cameras will have really nice resolution, some cameras not so much. And then importantly, you have to build it, because this is just a builder, and you need to convert that into a vision portal. So hence the .build method. Now, all of this stuff should be done on init, and then you have to do the wait for start command. And then all we're doing here is we're saying for AprilTag detection in the detections that are detected by the AprilTag processor. We're just adding to telemetry data about that. So we'll also explain this more in the next video. All of this code will be in the description, so you guys can copy it. But we'll explain more about what these values mean, like what's range, bearing, and elevation, and we'll also explain how to calibrate your camera in the following videos. So thank you for watching.